Hi, welcome to a new video. My name is Maggie from the Orients. On this channel, we explore anything and everything interesting from history, science, current events, true crime, and maybe even a bit of finance. Today let us explore an history and mystery of the once ninth planet. And on to the show. In the late 19th and early 20th centuries, one man's fascination with the mysterious red planet captured the imagination of both scientists and the public. Percival Lowell, an American astronomer and mathematician, embarked on a quest to unlock the secrets of Mars that would ignite controversy and shape the future of astronomy. Born into a privileged family in Boston, Percival Lowell's journey began with a passion for mathematics and the stars. He traversed the globe, exploring ancient cultures and absorbing the wisdom of the East, before establishing the renowned Lowell Observatory in Flagstaff, Arizona in 1894. It was there that he set his sights on the enigmatic world of Mars. What drove Lowell's obsession was his audacious theory that Mars was teeming with intelligent life. He believed that a sophisticated civilization had painstakingly constructed an intricate network of canals crisscrossing the planet's surface, a remarkable feat aimed at harnessing its scarce water resources. These alleged canals became the center of fierce scientific debate, captivating the public's imagination and sparking the age-old question: are we alone in the universe? Personally speaking, probably not. The observable universe is estimated to contain billions of galaxies, each hosting billions of stars. With such an incomprehensibly large number of celestial bodies, it seems improbable that Earth would be the only place where life has emerged. But extraterrestrial beings are likely not building canals on Mars. Despite facing skepticism from his peers, Lowell's meticulous observations and interpretations of Mars left an indelible mark on the scientific community. His theories challenged the conventional wisdom of a barren and desolate Martian landscape and fueled a wave of speculation about extraterrestrial life. The allure of potential civilizations lurking just beyond our reach gripped the public's imagination, permeating literature, art, and popular culture. Beyond his controversial work on Mars, Lowell's astronomical contributions extended far into the cosmos. His pioneering use of photography and spectroscopy revolutionized the field and propelled planetary studies to new heights. He delved into the mysteries of the outer planets and unraveled the secrets of Jupiter and Neptune. While his Martian canals may have been debunked, his pioneering spirit and tireless pursuit of knowledge laid the foundation for future discoveries. He propelled the field of astronomy forward, inspiring generations of stargazers to gaze beyond our world and wonder what lies in the vast reaches of the cosmos. The Lowell Observatory, located in Flagstaff, Arizona, was founded in 1894. The observatory has a rich history and has contributed to numerous astronomical discoveries and breakthroughs. One of the primary focuses of the Lowell Observatory has been the study of the planet Mars. Percival Lowell himself dedicated a significant portion of his career to observing and studying Mars. The observatory has always been at the forefront of technological advancements in astronomy. It was one of the first observatories to employ photography and spectroscopy in astronomical research. Percival Lowell himself played a crucial role in promoting the use of photography in astronomy, pioneering astrophotography techniques that revolutionized the field. Today, the Lowell Observatory continues to be a thriving center for astronomical research, education, and public outreach. It houses several telescopes, including the historic Clark Refracting Telescope, which Percival Lowell used to study Mars, and the 4.3-meter Lowell Discovery Telescope, one of the most advanced telescopes in the United States. The observatory conducts various research programs, ranging from studying exoplanets and asteroids to cosmology and galactic astronomy. In addition to Mars, the observatory has made significant contributions to the study of other planets, particularly Jupiter and Neptune. Lowell's investigations of these gas giants helped expand our knowledge of their atmospheres and dynamics. Lowell believed that there might be another planet beyond Neptune, which would be the ninth planet in our solar system. Lowell noticed that the orbits of Uranus and Neptune seemed to be influenced by some unknown gravitational force. He thought that this force could be caused by the presence of another planet far out in the outer regions of our solar system. He called this hypothetical planet Planet X. However, despite extensive searches, Lowell's ninth planet was never found during his lifetime. After his death, astronomers continued to search for this mysterious planet. In 1928, Clyde Tombaugh's cosmic aspirations caught the attention of the renowned Lowell Observatory in Flagstaff, Arizona. The observatory, captivated by his celestial drawings of Jupiter and Mars, recognized the brilliance that shimmered within him and extended an offer of employment. Thus, Tombaugh's voyage into the annals of astronomical greatness began. Clyde Tombaugh, born with an insatiable curiosity and an unquenchable thirst for the cosmos, Tombaugh's journey into the realms of astronomy would forever change our understanding of the universe. Hailing from humble beginnings in Streator, Illinois, Tombaugh possessed an innate fascination with the stars from a tender age. Armed with boundless determination and an unyielding spirit of inquiry, he embarked on a solitary quest for astronomical knowledge. Guided by the teachings of books and fueled by his own ingenuity, Tombaugh delved into the mysteries of the night sky. His awe-inspiring mission at the observatory was to aid in the search for a mythical ninth planet, postulated by the visionary Percival Lowell to exist beyond the far reaches of Neptune. Armed with a blink comparator, a contraption that flickered between two photographs of the cosmos, Tombaugh meticulously scanned the heavens for any signs of movement. The blink comparator enabled him to detect subtle shifts in position that could indicate the presence of an undiscovered planet. Tombaugh meticulously examined hundreds of pairs of photographic plates, each capturing a portion of the night sky. His objective was to identify any celestial object that appeared to move against the backdrop of fixed stars. It was on a fateful day, the 18th of February in 1930, that Tombaugh's tenacity bore fruit. Amidst the vast sea of stars, his keen eyes discerned a faint, ethereal wanderer, a celestial vagabond on a cosmic odyssey. Comparing photographs taken on different dates, he beheld the undeniable proof of his discovery, a celestial object that dared to defy convention. By scrutinizing photographs taken on January 23 and January 29, he spotted a faint object that appeared to have shifted in position. Further examinations and comparisons confirmed the reality of his discovery. The newfound celestial body lay far beyond the orbit of Neptune, defying the expectations of astronomers at the time. Given its distant location, Tombaugh's discovery indicated the presence of an elusive ninth planet. News of Tombaugh's monumental find cascaded like a meteor shower across the globe. The world stood in awe, captivated by the audacity of this intrepid explorer, who had unearthed a celestial gem. Overnight, Tombaugh ascended to astronomical stardom, his name inscribed among the titans of discovery. March 13, 1930. The name Pluto is officially suggested by an 11-year-old British girl named Venetia Burney. Her suggestion gains widespread acceptance. Yet, Tombaugh's celestial voyage had only just begun. Tombaugh dedicated his life to unraveling the enigmas of Pluto, peering through telescopes to unlock its secrets. He journeyed through the cosmos, delving deeper into the realms of astrophotography and planetary science, leaving no celestial stone unturned. While his contributions to astronomy were manifold, it was his audacious discovery of Pluto that would forever etch his name in cosmic history. Tombaugh's unwavering pursuit of knowledge and his unrelenting quest to unravel the mysteries of the universe stand as a testament to the indomitable spirit of human curiosity. Then in 1978, the discovery of Pluto's moon, Charon, provides valuable information about Pluto's mass and size. Move forward to the late 20th century, and advancements in technology and improved telescopes enable astronomers to discover other small objects beyond Pluto, known as Kuiper Belt objects or KBOS. And with these discoveries come questions of what is Pluto. The Kuiper Belt is a region of our solar system that extends beyond the orbit of Neptune. It is a vast disk-shaped area composed of small icy bodies known as Kuiper Belt objects. The Kuiper Belt is named after Gerard Kuiper, a Dutch-American astronomer who predicted the existence of such a region in 1951. KBOS are remnants from the early formation of the solar system and are primarily composed of rock, water ice, methane, and ammonia. They are similar in nature to Pluto and other dwarf planets found in the region. These objects vary in size, ranging from small bodies measuring a few kilometers in diameter to larger objects like Pluto, which is about 2,376 kilometers in diameter. In 2005, the dwarf planet Eris, which is slightly larger than Pluto, is discovered in the Kuiper Belt. This leads to a reevaluation of Pluto's planetary status. Pluto's status as a planet has been a topic of discussion and controversy in recent years. Prior to 2006, Pluto was considered the ninth planet of our solar system. However, in that year, the International Astronomical Union, or IAU, redefined the definition of a planet, and Pluto did not meet all the criteria. According to the IAU's definition, a planet must orbit the Sun, be spherical in shape, and have cleared its orbit of other debris. Pluto fulfills the first two criteria but fails the third because it shares its orbit with other Kuiper Belt objects. Therefore, the IAU reclassified Pluto as a dwarf planet rather than a full-fledged planet. The discovery of numerous other KBOS in the Kuiper Belt, some of which are comparable in size to Pluto, played a significant role in the reclassification. These findings highlighted the dynamic nature of the outer solar system and the existence of a population of similar objects. As a result, Pluto's reclassification acknowledges its membership within the Kuiper Belt and its shared characteristics with other KBOS. The craziest thing about all of these was in January of that year, 2006, the New Horizons, a space probe made by Johns Hopkins University Applied Physics Laboratory and the Southwest Research Institute, was launched, and its mission, to perform a flyby study of the Pluto system. Its secondary mission was to fly by and study one or more other Kuiper Belt objects in the decade to follow. After years of planning and multiple proposals, then the mission was launched, and the powers that be declassified Pluto. Insane. It's important to note that the reclassification of Pluto does not diminish its scientific significance. Pluto remains a fascinating world worthy of study, and its exploration through NASA's New Horizons mission in 2015 provided valuable insights into its geology, atmosphere, and the nature of Kuiper Belt objects in general. NASA's New Horizons mission provided a wealth of new discoveries and insights into the nature of Pluto. Geology. New Horizons revealed a diverse and complex surface on Pluto. The mission discovered towering mountains of water ice, some of which reach heights of up to 3,500 meters, 11,000 feet. These mountains suggest that geological activity, such as cryovolcanism, may have shaped Pluto's surface. Heart-shaped feature. New Horizons imaged a prominent heart-shaped feature on Pluto's surface, which was informally named Tombaugh Regio, after Clyde Tombaugh, the astronomer who discovered Pluto. This feature, also known as Pluto's heart, consists of a bright, nitrogen ice-filled basin called Sputnik Planitia, surrounded by darker terrains. Atmosphere. The mission provided detailed information about Pluto's thin atmosphere. New Horizons discovered that Pluto's atmosphere is composed mostly of nitrogen, with traces of methane and carbon monoxide. It also revealed a haze layer composed of complex hydrocarbon compounds. Moons. New Horizons confirmed the existence of 5 moons of Pluto: Charon, Styx, Nix, Kerberos, and Hydra. Charon, the largest moon, was found to have a varied terrain with a vast chasm named Serenity Chasma. The other moons also exhibited interesting surface features. Icy plains. New Horizons observed large, smooth regions on Pluto's surface, known as Sputnik Planitia and Voyager Terra. Sputnik Planitia is a vast nitrogen ice plain, while Voyager Terra consists of rugged highlands. Composition. Through spectroscopic analysis, New Horizons provided insights into Pluto's surface composition. It detected a diverse mix of ices, including nitrogen, methane, carbon monoxide, and water ice. These ices give Pluto its distinct reddish-brown color. Exploration of the Kuiper Belt. After its flyby of Pluto, New Horizons continued its journey into the Kuiper Belt and conducted a close encounter with another KBO named Eriketh, initially known as Ultima Thule. This encounter provided valuable information about the formation and evolution of these ancient objects. Pluto, the celestial object that used to be the ninth planet before it got downgraded like an unpopular celebrity. Poor Pluto. It went from being a full-fledged planet to a dwarf planet status, causing all sorts of cosmic controversies and drama that even the astronomers could not agree on. But the New Horizons mission swooped in, capturing all the juicy details about Pluto's life. We discovered that this little guy has quite a complex surface. Imagine towering mountains of ice that could make the Himalayas jealous. Who knew Pluto had such fashionable taste in landscapes? Of course, Pluto has its celestial entourage of moons fit for a star, or a dwarf planet in this case. Pluto's status as a planet has been a subject of scientific and public debate, and the reclassification by the IAU remains a topic of discussion among astronomers and the general public. Nobody can agree on anything. The primary point of contention revolves around whether Pluto should be considered a planet or reclassified as a different type of celestial body. Alan Stern, an American engineer and planetary scientist who spearheaded the New Horizons mission, said the New Horizons project will not recognize the IAU's Planet Definition Resolution of August 24, 2006. He also said, "I am just disgusted by the way the IAU, which is meant to represent the best in science, handled this matter, and we do not classify objects in astronomy by what they are near. We classify them by their properties." Supporters of Pluto's classification as a planet argue that its historical status as the ninth planet should be respected, and that the IAU's definition is arbitrary and overly restrictive. They believe that the criterion of clearing its orbit is unfair, because Pluto shares its orbit with other icy bodies in the Kuiper Belt. They also highlight that the term dwarf planet is confusing and can lead to misconceptions about Pluto's significance. On the other hand, proponents of Pluto's reclassification argue that the IAU's definition is based on scientific principles and is necessary to maintain clarity and consistency in planetary classification. They argue that the criterion of clearing its orbit is crucial because it distinguishes planets from other smaller bodies that share their orbital neighborhood. They contend that Pluto's orbit intersects with Neptune's, and it has not cleared its orbit by gravitationally dominating its surroundings, unlike the 8 planets recognized by the IAU. From a scientific perspective, both sides present valid points. The definition of a planet is not a purely objective matter. It involves a combination of scientific considerations, historical precedent, and human interpretation. The IAU's definition attempts to establish a clear and consistent framework for planetary classification, and it has sparked debate and disagreement among scientists and the general public. It is worth noting that scientific understanding evolves over time, and classifications are subject to revision as new data and insights emerge. Future discoveries and advancements in our understanding of the solar system could potentially lead to further refinements in the classification of celestial bodies, including Pluto. Ultimately, the debate about Pluto's classification highlights the complex nature of scientific categorization and the interplay between scientific principles, historical context, and human perception. While the IAU's definition currently stands, the discussion and reevaluation of planetary classification remain ongoing in the scientific community. Thank you so much for watching. Please share, like, so others can see this video, and subscribe for future ones. Make sure to check out NASA's In-Depth and their solar system overview powered by NASA's eyes, which is pretty neat.